Our next speaker is Mark Antonacci. Mark has studied the shroud for over 40 years, advocating for advanced minimally invasive testing to determine its age and the cause of its unique features. He suggests that scientific analysis could prove whether a radiating event occurred to the crucified body wrapped in the cloth. An attorney and author, he wrote The Resurrection of the Shroud, published in the year 2000, and Test the Shroud, which was published in 2015. And he's working on a new book called The Shroud of Turin 101. He also founded and leads the Test the Shroud Foundation, a nonprofit organization dedicated to scientific research on the shroud. Let's welcome Mark. Wait a minute. Needs to mic you up. Oh, Dave will mic you up.
Your lapel of your jacket.
Okay.
You should be good.
Where do you put that? Where do you put that glass of water?
Is there anything that has his water? Excuse me. Do you have his water?
I have his water.
Where did John?
You asked me if I have water for it. Yes, this is your water, sir.
Oh, that's what I wanted. Thanks.
I give it to you and you give it back and I keep it over here as needed.
Oh,
Got it? Easier?
I could spill it by myself.
Anointed by yourself.
The book that I'm working on is actually you change the title as you go on, but it's the how to easily solve the greatest and most controversial problems of science and humanity. And I'm sure I can cover that in 45 minutes, But at the core of what I'm doing is proving that the carbon dating of the shroud is incorrect because it was irradiated with neutron flux. And the reason the carbon-14 dating is the most controversial problem in science and possibly humanity is because it's just inconsistent with all the scientific, medical, anatomical, the physics, the chemistry, the medical, the art history. You could go on and on and on with these categories. And it's inconsistent with that. And
This will advance the slides, and that will go backwards.
thank you.
You're welcome.
It's not only consistent with this being Jesus' burial cloth, but all the evidence indicates that this man has been scourged, beaten in the face and the head, crowned or capped with a sharp-pointed objects like a thorn. All the postmortem side wound, the watery fluid, and all the wounds, under all the circumstances, on the same circumstances of time, location, executioners, barriers, their compliance with Jewish burial customs to the final detail of ancient Jewish burial customs in a provisional or hurried burial. They all point to this being Jesus. And you have one date that's inconsistent with this, and that's the carbon dating date. And yes, it reminds you of the unfounded, centuries-long conclusion that the shroud was painted. And so we need to bring this to a test. Part of the reason, a huge part of the reason why we need to conduct more tests on the shroud is because of the very careless, hasty way they did it. And they couldn't have done it worse. You have to realize they got 18 measurements from the shroud, and they were all correct. They were accurate. It showed a variance. When you take their original measurements plus their own plus minus uncertainties that are measured from the sample that were sent to the laboratories, you have a 4-century age range. For a little piece, 3 adjoining pieces that combined are 2/3 of an inch by 1.5 inches. And these laboratories, they're used to just working on one sample by themselves. This was a new method then. And they've never dated the sample that was irradiated with neutrons and has thus created even more carbon-14 atoms. Even down in the little corner where the sample came from, they still would have received enough radiation, neutron radiation. It's parallel with the man's ankle, about 18 inches away, near the corner. It's not going to get nearly as much radiation as the part of the cloth that's over the body or under the body, or the blood that's chemically rich and would convert these neutrons to carbon-14 much quicker than linen would. But it's still, if you calculate the additional neutrons they received, it's probably about twice as much even there in that corner. Well, what they're doing is the labs are dating carbon-14, they're measuring carbon-14. When you measure carbon-14, the amount of the carbon-14 to carbon-12 ratio is known in all living things. It's very, very similar. And no matter how big your sample is that you want to measure, if you know the sample's areal density, length, weight, height, density, mass, weight, all that stuff is in the areal density. If you know the oomph in the sample, and you know how many neutrons irradiated it, you can tell how many carbon-14 atoms would appear. They occur at a known rate, and they decay at a known rate. And when the organism, a flax plant, dies, when it's harvested, it starts decaying or disappearing at a known rate. And this is true also for chlorine-36 and for calcium-41. And blood is much richer chemically. So you would see more chlorine-36, more calcium-41, and more carbon-14 in an irradiated blood sample that may be a fraction of the size of a piece of linen, because there's more nitrogen in the sample. Neutrons will hit nitrogen sample, hit the nitrogen within the sample, and it will create carbon-14 atoms. Same thing for when it hits the chlorine-35 atoms inside the sample, it will create chlorine-36 at a known rate. And it will disappear at a known rate. Same thing for calcium-41, calcium-40. Well, when you carbon date, you just measure the carbon-14. They assume it's just the original carbon-14 that was created in the atmosphere. I don't want to take up too much of the 45 minutes on, but you all know that, and John Jackson covered it well. And it's just created from the atmosphere, spread throughout the biosphere, and it's at a known rate. And so when that sample was harvested, they know, no matter what the size, they can tell from the areal density how many carbon-14 atoms were in there. And by the way, the conversion to carbon-14 occurs because neutrons in the atmosphere hit a nitrogen atom. And the atmosphere has 78% nitrogen. So that's how it's created, and photosynthesizing plants take it up from the gas and distribute it. Well, that's all they measure. They know how much, they can calculate from your sample how many carbon-14 atoms were in that piece of flax when it died. And now they measure it here, again in 2025 or 1988. And they know the decay rate. So they know how much they measured, they know how much was in it. It's just a matter of subtraction because you know the rate they decay. And they say, oh, well, this was 1,200 years ago or whatever. Well, they get their dates, and they got this problem. Now, the first mistake they make is the laboratories were supposed to send their samples to not only the British Museum, but to the Institute of Metrology. Metrology is the science of measurement. And they never sent anything to the Institute of Metrology, nor did the coordinator of the carbon dating project, the British Museum, send them a copy as the scientific protocol clearly called for. And at no time did they share any data with him, and it also required them to have subsequent follow-up meetings of what they did with this preliminary data. And there was no such meeting like that. And what they did, they took, these data are heterogeneous. They shouldn't be 4 centuries apart in their uncertainties on a 2/3 by 1.5 inch sample that are contiguous. So, and the ages range from the 500s to the 800s. So, in age, in years. So they start averaging them. Well, and it's a 2-for-1 swap. They take 2, and it eliminates the highest and eliminates the lowest. And replaced with an artificial, unmeasured age. And they do this, well, Tristan discovers most of it. Remy Van Helst discovers that they did this with Arizona, which had 8 measurements. And they narrowed it down to 4. They're tightening them up, making them look uniform, which is the same thing they did in the Trondheim experiment. And one of their experiments out of the 3 dates at Trondheim, 5 laboratories completely missed it. But they didn't care. They were all nice and tight. And their response was, you must have the wrong age. All of our dates are nice and uniform here. Something's wrong. They didn't care a hoot about it. And we're underwriting the final thing on the Trondheim report. He says, well, as it turns out, they were wrong. They were probably wrong that the sample was dated to half its historical age. But there was no, when Zurich dated one of the 3 samples 1,000 years too old and 1,000 years too young. Zurich went through all kinds of processes and improved this. They were using a new pretreatment method. It took them a while to work it out, but they worked it out. But these other guys, they didn't care. Well, it's not that they didn't care. They just, for whatever reason, they didn't do it. And the effect of not sharing the data with the scientific, the Institute of Metrology is, nobody else can say to them, look, I think you've got an outside source of carbon contamination. They never thought that the carbon content is different on its own, and you're correctly measuring it. So they continue to average it. They don't share it with anybody. The Institute of Metrology doesn't know this. Pope John Paul II didn't know it, and he owned it. And the world didn't know it because it wasn't in the official report. Give a hand to Bobby. And thank you.
The best.
Yeah,
The best.
I'll do my best not to knock it over, but no guarantees.
2 hours. Time.
Yeah. So that's what they did. The main thing they did wrong, they put it all, the average age out of 18 original measurements, and Tristan will have more next hour. Out of Oxford, when they heard what the British Museum requested Arizona to do that, and they said, yeah. And I don't think Arizona realized you can't do that with heterogeneous ages. You lose the information you're trying to know. Let me give you an example. If you had $50,000 in a bank, in a CD or savings account, and you had another $5,000 in a checking account to pay your monthly bills and put your paychecks in. If the bank came to you and say, we took your two accounts and averaged them into one for $27,500. And you go, that's embezzlement, you know? That's wrong. You took the relevant information, the amount, and measure. In 1962, Wilt Chamberlain scored 100 points in a basketball game. It had never been done before or since. If the next game he was tired or not feeling well and only played a couple minutes and scored 2 minutes, what if the official score or the sports writers merely wrote, Wilt played both games and averaged 50 points? You go, what? First of all, they're missing the most relevant and important information of all, and that's the counting of his points. He scored 100 points. It might have had something to do with how they won the game, you know, and it was very relevant, you know. So you can't do it when it's heterogeneous. If Wilt had scored 52 one game and 48 another game, sure, that's homogeneous. And you could say, yeah, he averaged 50 points a game. And you wouldn't be off very much at all if you put that in the official scorecard. Well, that's what they did. With 14 out of 18 and counting, Tristan's going to give us more. And Zurich, that Arizona and Oxford did a 2-for-1 swap. It should be a 2 for none because the one thing is worthless, but it's the number they like. And Zurich did a complicated one, but it was a 2 for 2. But it still made their samples 106 years older, which was more consistent with with Oxford's right next to them. So that's what Remy Van Helst means when he says they played a little fast and loose with the numbers. I'm not sure they realized it, again, that you can't, it's statistically unsound. And I'm not sure they never had this problem before. but they never shared it. Ganella was a professor of physics at the Turin Polytechnic Institute, and he had to have known of the colleagues that Ganella specialized in metrology. He had to know of colleagues at the Institute of Metrology. They have long-time connections in Turin. And they could have easily went there and said, oh, we'll ask Luigi to get us another sample, which had been the plans in the previous protocols to use more than 2 samples. But Harry Gove made sure Stirp had nothing to do with even picking a sample, and would not undertake testing in 25 other areas, or otherwise he was going to pull the labs out of the project after about 8 years of fiddle-faddle, and I'm being very generous when I say fiddle-faddle. And that it was, we, the carbon datings, are one of the sole group under the limelight, I think. But at any rate, they made mistakes on 2 ends, and they never asked for another sample. And Hedges even brings up a point that you would have additional chlorine-36 that would have been formed. He's correcting Thomas Phillips, who says it could have converted from carbon-13 to carbon-14, and that's true, but nitrogen will work much, much better, and you could use 1,000 times less energy in your radiation. And he even says this. And, but what's the chances of that happening? You know, basically what he says, and he just gives you reasons why you can't. But I think, why'd he say it? But I'm glad he said it, because you could, and he's talking about it now on a letter to the editor in response to Phillips, and this is after it's all over. It's in the same issue that the carbon dating report officially appears in the Nature journal in February 1989. Well, he's got the wrong, it's on the back end. You want to make that measurement on the front end. If you take a sample and measure its chlorine-36 to chlorine-35 ratio, because it is formed at a known rate and it decays at a known rate, you can backtrack from the formula and calculate how many neutrons hit that sample that created the chlorine-36 in there. All you have to do is when you take your areal density of your sample, also measure the sample's nitrogen content, which I won't get into all to, but you could do that with a tiny sample. And you would know how many additional chlorine-36 atoms figured in there. And it's going to show up just like the carbon-14 at a known rate and all that stuff. And it would have decayed since that event. Here's the thing. People think, well, you can't figure out when that event happened. That's not true. It could have only happened in 2 different eras. One from 1932 to 1988 or 2025. Neutrons weren't even discovered till 1932. No human could have irradiated that cloth except that time period. But he would have needed a nuclear reactor back then. And the other time is when this bloodied, crucified, tortured man, when a miraculous event is alleged that happens to him in either 30 or 33. There's no in between. Well, the half-life for chlorine-36 is 301,000 years. In 2,000 years, less than 2/3 of 1% of the chlorine-36 would have decayed. okay, let's be as independent as possible. Let's backtrack the number of neutrons that would have irradiated the chlorine-36 sample. And that alone will give you something almost right on the money, right on the dot. It's 99.333 plus % still on there. And at the end, you could add on another 0.2% if you want and get yourself another 10 years or whatever the figure will be. But you can go with that number right there. At minimum, it was irradiated with that many neutrons. And now you know how many neutrons were there. Now you can calculate from that sample how many additional carbon-14 atoms that created. Put that at the top right-hand corner of your page. And what's left of the carbon-14 would be the form that was formed originally in the sample. This is the same formula as carbon dating. They know how much was originally there and how much is left now. That's what we're going to be doing with the additional carbon-14 atoms created by the neutron flux on the Earth from that dead crucified corpse wrapped in the cloth. How many hit that sample? And you put that in the right-hand corner. Now look at the total amount and attribute, it's roughly twice as much on that sample. Like I said, if you did a sample, if you counted the ones that was on the body, that sample would date well into the future, especially if you got some of the blood on the body, and 99% of the blood is on the body. But it would date way to the future. You'd know immediately your conventional carbon dating was wrong, very, very wrong. But take the ones that we put the ones that were created by the neutron flux in the right-hand corner, and we can calculate that, and that's the minimum amount that it hit because we're going on today's ratio. And then take the leftover carbon-14, and that goes on the left-hand column. And you know how much was in that sample. You subtract that column. And say it's 70-30 originally. Then you take it out, it's 70-30 down at the bottom, and you measure the difference. On the left-hand column, you're measuring how old the sample is. The right-hand column, you're measuring when the event occurred, or how many years ago the event occurred. And it's the same calculation. You're starting with the number of carbon-14 atoms that was in there right at their opportune, at their highest amount, when the flax was cut and when the radiating event occurred, because they both start decaying after that. Well, the flax was cut maybe months before the event. And in carbon dating terms, that's nothing. Joseph of Arimathea purchases a new linen cloth on the way back from getting permission from Pontius Pilate to bury the man. And the neutron flux from the body, the postmortem watery fluid, all that's within, a couple of hours of each other. The body dies, the blood starts dying when it's shed from the body, although it's still going to coagulate and all that stuff. But the times are all together. It's easily within the time frame of 30 to 33. And they're decaying at the same rate. You're making the same measurements, the same calculations as you would on a carbon-14 date, except you're doing it twice. You're separating the carbon-14 created by the neutron radiating event from those originally created in the atmosphere and taken up by photosynthesizing plants. And you take the percent of the total, the 30%, and that tells you how old it is, and you take the 70%, And that tells you how long ago it happened, but it's the same measurement. You're just measuring the decay rate, and that'll tell you how many years ago. You can carbon date it, and you can make the little correction about a little bit of extra neutrons that would have hit and make it a little bit older. Your number on the top would have been a little bit older. You could play around with that 0.2% if you want. But you'll easily see what era it's in. You will easily know that, and you can calculate it just as good, I think even better, than a regular conventional carbon dating. And that's what they did. They gave it the regular conventional carbon dating and said, oh my God, we got to start doing something. And that's what they did. They started, and we're not going to tell anybody. And because they never shared anything with the Institute of Metrology, nobody knew until Tristan Casabianca, Emanuela Marinelli, and 3 other people whose names I don't have in front of me, filed a Freedom of Information Act against the labs and the British Museum. And originally, the labs didn't even respond. But the British Museum, to their everlasting credit, responded. And all those, all these dates are just partial dates. This sample we hope is left, and this sample we hope is left. It's plenty of sample to do a chlorine-36 sample from. You could do all of them with pieces from the reserve sample. In Arizona too, it's big enough. And the blood, my gosh, you only need literally, in layman's terms, a drop of blood to measure the chlorine-36 to 35 above background ratio, 41:40, calcium 41:40, and carbon 14:12 ratios, a drop of blood. Now, I don't know if any of that's handy, but you could easily take some from the back side, but you could easily perform more carbon-14 dates on there. And the blood, in 2002, in the Sindoni 2002 book, he describes when they took the backing cloth off and replaced it, they saw some threads hanging out the back side. You know, like one would hang on your coat or something. And they just snipped them off, you know, for conservation purposes. And 2 of them are 1 centimeter long, which by itself you could do a carbon-14 dating, and you could also measure the nitrogen from that. And on the back side, off to the side here, the blood is embedded in the cloth. You can see it on the back side as well as the front side. But you could take some from the back and nobody would really see it. It's covered with the backdrop. And you could easily do that. You could not only prove whether the sample was irradiated with neutrons, the number of neutrons each sample received, whether that would have affected the carbon dating, and any small bit would have affected it, the real age of the sample, when the neutron radiating event occurred, and whether the body was the source of the radiation, or just attend Bob's MCNP talk, because I can't dream of getting it in the next 15 minutes, you know. And, but generally, the correlation is going to be the closer to the body, the more neutrons it received from the body. And the parts that were closer to the mass is going to get more than a part at the ankle. And the backside that's laying on the limestone shelf is going to get 2 doses. It's going to go through once and then rebound or ricochet and go through again. So you're going to get a lot more on the dorsal side. And they've got computers that can figure these things out. And, but that's generally how you tell the source. And if you took a sample from the tomb of Christ, if you've got calcium-41 in that limestone, and there is calcium in the limestone, that would prove where the radiating event occurred, because it does not occur naturally in limestone. I'm talking about above background levels, not infinitesimally small levels from spallation. And you would be proving that neutrons irradiated from a body. That has a huge implication. The man's hair, neutrons from, well, radiation, I had to cut it out. There's 33 indicators on the body image of body image features. Only radiation could explain or cause all of these 33 features. You only find them on the frontal and dorsal full-length body. You can figure out the source there, and it has to be the body. All the information that's coming from the body by light is going there. And this is just one feature we're talking about, the positive and the negative on the cloth. There's 32 others. But all the information from that body is going by way of light. If it's protons, neutrons and protons are paired together within the nucleus of all atoms. And if a man's giving off neutrons, he's starting to disappear. If he's giving off neutrons and protons, you can double, that's twice as much. Now, it just happens for a fraction of a second. If it had been on longer, there'd be a big blur. So he's just starting to disappear. It's like on takeoff to another dimensionality, it gives off a little spark uniformly. And it's probably just as superficial as the either UV light or proton light or something we don't even know about yet, but that comes off the body. And but that body is starting to disappear. You've got miracles on several levels here. The neutrons and protons have to overcome the strong nuclear force, and it's coming from a dead, crucified body who's been in a cold tomb in rigor mortis for a day and a half. And it leaves an unprecedented full-length images, and it creates radioactive atoms all over the cloth in proportion to the body. You've got really good proof that makes so many of the other stuff seem piddly. You've got proof of a miraculous radiating event of a guy who suffered all the wounds of Jesus at the same time, in the same location. You've got proof beyond a reasonable doubt. That goes to the other end of the title, the first part of the title. How do you solve the greatest problem in life? Which is, you're going to die. Inevitable, unavoidable, you're going to die. And you're going to cease to exist. Spiritually, physically, any way you want it. But if this guy did all those suffering, and he clearly says why he did it before and after, and he waits, he goes through 2 or 3 trials, he doesn't speak up, he goes through all this suffering, all that, only after he's dead does it access the power to come back to life. He can do it. He can pull it off. And he's the guy telling us, we too. So this is all worth looking into. And there are samples that could easily be taken. And you have everything to gain and nothing to lose. If you want to keep your samples, whether you're a lab or Turin or whatever, if you've got a sample that's from medieval times, you really have nothing. But if you have a sample from the time of Christ and it's got all this proof in it, now you've really got something. And you can share it with everybody. That's your value. Cashing it in. Okay.
Yes, where are those remaining surviving samples and who owns them?
Tristan will tell you more about that. And I imagine the reserve sample, I think when I fell down there, I knocked the location of the samples off the screen. But the reserve sample was the big one. And that's probably in Rome. I don't know. Yes, I asked around a few people, and they're not sure either. So that's probably good. They want to keep it there. The labs do have some additional samples, and Arizona has that one sample that's about 13 millimeters, and that alone might be enough. And the good thing about it is, once you do a few blood samples, correct me if I'm wrong, or any physicians here, but the amounts of nitrogen and chlorine and calcium, while they could change on a linen, in your blood circulates, it's probably just about the same, whether it's a head wound or a foot wound or anything in between. The amounts of those chemicals on the shroud, you wouldn't have to start all over and measure the chlorine and the calcium and that stuff.
Yeah, thank you, Mark. Yeah, chlorine's a pretty predictable amount in extracellular fluid. Calcium, I imagine, is too. My question, though, is, I think being the devil's advocate, what about contamination?
Yeah.
Because calcium is in stone, carbon is pretty ubiquitous everywhere, but chlorine probably, could you have chlorine contamination? Is there any, have you looked at that?
They got to pre-treat and clean it anyway for carbon and that. So you're talking about with blood?
Well, yeah, with the samples.
Or linen.
Yeah, with
That's
the
just routinely done with linen.
It's cleaned, okay.
Yeah, but you don't lose much. The linen's in there. The blood, now that'll be harder. But I'm working with a radiochemist, and Thurman Cooper, his name will be on here, as will Art Lenz. And they've got new devices now with lasers that can just shave the edge of the blood off. And now you're left with your pristine sample there, because it won't penetrate. It'll stay on the surface. So you just shave the surface off.
Okay, thank you.
Tom.
Just to point out that when I did my experiments with modern linen and had it neutron irradiated, we took one piece, and it was a small piece, and sent it to Lawrence Livermore and had the chlorine 36 to 35 ratio measured. And the fluence that we used was comparable to what would have caused the radiocarbon date to change from first century to medieval.
You bet.
And the chlorine 36 to 35 ratio was 2,000 times higher than that would occur naturally in the linen. So that is a very real possibility that you could take a piece of linen and test for chlorine-36 and get some interesting results. It was just one piece of linen, and it was a small piece, but it did increase it by a factor of 2,000, if I remember the numbers correctly.
I remember when you did that. Yeah,
I wanted to explain my, real quickly, my understanding of one thing and see if you know or if I should save it for the next. I think it's a catch-22 from what I've seen that the Vatican or one of the cardinals had asked everybody that has samples outside to bring them, to send them in. And if you didn't do that and you tested something, let's say Arizona has kept that smaller strip, and they tested it, you have immediate rebuttal from anybody who is a non-believer would say that it doesn't have the provenance because you're not allowed to have the authentic fabric.
I'm a lawyer, and a chain of custody that you need, it doesn't have to just stay in its original place. That kind of argument, you'd say, well, somebody in 900 did something to it that they didn't know about in 1500 when it got to Turin. You can have a chain of custody as long as you know. If the laboratories have kept it, in a safe or somewhere where only they had access to it, that qualifies as in the chain of custody. You don't have to destroy it every time you use it or test it. You can keep the material. You just have to establish a chain of custody.
Okay. I just remember some of the more recent testing was done, and that was the response. Well, we can't tell you that this is original. I get the chain of custody, and I'll have to think about that. But we can't tell you this is original because we told you to send everything back that was original.
What if
you're still sitting on it, it's not original.
What if it dated to 2000?
Yeah.
Consistent with that, I've played devil's advocate with myself for hours on end, and finally realized you could think, well, maybe a forger after 1932 or between 32 and 88, or when they started getting these portable neutron radiators, maybe he did all these calculations and irradiated the cloth. Bob's got, what, thousands of points of information on a full-length 14.5-foot cloth. But maybe he, a mad scientist who worked for years with this, and I don't know how he got the shroud for years, but anyway, and could put them all down there. But the only way you can get those numbers to match what they really test results are is to have done it in the year 2000 and to let it come from a body. You can't fake it.
We have time for one more question.
Hi, I don't in any way dispute the power of the resurrection. I don't understand how it happened, but I don't dispute it. But could you look behind you at the image that Barry created from the shroud and have a look at the carbon date area that is so clear on it? Why is it a different colour to the area that's next to the face of the man of the shroud?
This picture was taken probably in 78.
That's exactly, so it predates the carbon dating. So the bit that was carbon dated is there on it, and you can see the colour.
Well, that's the background cloth.
No, it's not.
Right here, this little patch, this little bare spot, that's the background showing through.
It's not, it's the shroud. It's what they cut, it's what they dated.
Well, if they cut it and took it off, how could it be the shroud?
But no, sorry. Barry's photo is from 1978. They cut it in obviously 1988. And the area, if you compare the modern day look of the shroud with that, you see that what they cut off is the bit that's discoloured.
You're talking about here, or are you talking about some area next to it?
No, I'm talking about...
The area next to it is, there, you got that too. That's the area next to it. Those samples are gone, and that would have been next to the bare spot in 78 when that picture was taken. But that area is it's the worst area of all. Stirp knew every inch of the cloth, every centimeter of the cloth, And they would have never taken one from there, and they would have taken it from 2 or 3 pieces, and they said that ahead of time. But Harry Gove insisted that Stirp plays no role whatsoever. But yes, there's scorch marks there. There's a water stain there. But that,
Excuse me, sorry, that's not a scorch mark. If it was a scorch mark, all 4 corners would be missing.
well, it's not as strong as some of the other scorch marks. Well, what do you think it is?
It's dye.
Well, at any rate, all of these things would have been removed with pre-treatment cleaning. Well,
I'm so sorry to keep pushing this point. Oxford used 1.5 N of hydrochloric acid. That would not have removed the dye or the gum that was on the shroud. Sorry, forgive me, I'm hijacking this.
well, I can't give you an answer that you would accept.
Okay, we're going to have to end here, and Mark can go in the hallway afterwards, and you can catch him out there.